Hey there, this is Robert Kornacki, co-founder at Paima Studios and leading design and development of Paima Engine. In this video, we're going to be doing a developer deep dive at both the architecture level and with a nice overview of what it means in practice to actually write games using Paima Engine. In this video, we want to kind of focus on the basics of what is Paima Engine for a developer, what are the different parts at an architectural level, and then once we have that higher level understanding, jumping into the code and at least looking at a basic game example with the game of chess implemented in Paima Engine. Just how does the actual code in practice end up going and applying on top of the architecture that we'll look at in the first place. So without further ado, let's jump right in. Okay, so looking at the architecture diagram, you can see here, we're going to zoom in into each one of these parts and kind of go over what they do and how they interact from the player perspective and from the developer perspective. At the top here, you can see that we have the game front end. The game front end is pretty much what the users see, and this is what most game developers by default understand game development to be. So this is using Unity, Unreal, building apps, games for Android, iOS, web, using gaming frameworks. These are all things that are more client-sided, front-end based, and these are things that the user actually sees when they play their game, your game. And so all of the front-end code is using the exact same stack that you're used to, whether that's Unity, Unreal. Eventually, we'll probably add support for Godot, Game Maker Studio, and all of these more popular gaming engines. And effectively, building out your game in the front end, that part of the stack is about 90 to 95% already what you're exactly used to. However, obviously, your front end needs to connect with the rest of the stack, meaning the blockchain, your game node / backend, and everything in between. So the front end is quite simple to understand. And moving from the front end, we get to our first new part of Paima Engine, specifically in the middleware. The middleware is a piece of software, primarily in TypeScript / JavaScript, that interacts with everything else from the blockchain itself, code from the backend / game node, and actually talking to the game node via the web server. All of this is coordinated by the middleware. And so when you write a game, we have a middleware core library that abstracts all the Web3 wallet details. So you don't have to understand how to interact with MetaMask, how to interact with Flint, how to interact with Polkadot wallets. All of this will be baked in, and you simply just have to import and use it, and it's all included. But for your game specifically, depending on the type of game you write in Paima Engine, your middleware needs to interact with your game node to fetch what's the latest state of this lobby, what's the round number, did the opponent submit a move. These are all things about global game states that have to be fetched from the game node. And the middleware provides an interface for the front end to then interact with all of this. So an endpoint called user wallet login to log in with the user's wallet and get back their address, endpoints for fetching lobby state, and then endpoints also for fetching and executing a round executor. A round executor is effectively, without getting too nitty gritty, it's effectively a sub-state machine of your entire game. To make that very simple, all this means is that when users play and experience actual gameplay as a part of your Paima Engine-based game, there are two parts to every piece of gameplay. There is the quote-unquote backend part, or the game node part, where your actual global state has to change. But then we actually need to visualize and show the player what happened in that gameplay. And so to do that, we have this novel concept called a round executor, which enables us to fully deterministically exactly replay a full match and emit events from every single moment in that round, in that match. And this concept of rounds and matches actually can expand to effectively be any type of state machine. So in other words, this doesn't have to be in a lobby system, but you can code arbitrarily complex round executors to build pretty much any type of gameplay that you want for your game that works fully on the backend side and then is fully replayable with the round executor interface on the front end side. And so the middleware talks to the backend and has the code to initialize a round executor for your game so that your front end has the ability to then replay a round or any like subsection or subpart of core gameplay and replay that fully tick by tick by tick to then visualize it on the front end. And so these two pieces, the middleware and the round executor, are absolutely vital for your front end to be able to actually fully provide users what feels like gameplay. Moving from there, so we talked a lot about reading from the backend via the web server, but the middleware also writes. And so the middleware, as I mentioned, we have a library that is included, which provides all the wallet interaction interfaces for you. So when a user seeks to perform an action, they, like in Jungle Wars in the front end, maybe it's in Unity, the user selects 3 moves they want to submit for a specific round. They click the buttons in the game, and then afterwards they click submit. That goes to the middleware. The middleware sees, the 3 actions the user chose. It then takes those 3 actions, encodes them in something called concise encoding, and then it takes them and submits it to the user's Web3 wallet. The user's Web3 wallet, whether that's MetaMask, Flint, a Polkadot wallet, or whatever, it then signs and creates a transaction. And then through that, it then submits it to the smart contract. Alternatively, for Cardano wallets, Polkadot wallets, and non-native EVM wallets, there's also an in-between step with Paima Whirlpool, but for now we can ignore that and just assume the wallet directly submits the game input that was initially submitted by the user on the front end, which got passed to the middleware, encoded, submitted to the wallet, signed, and then posted on chain to the Paima Layer 2 smart contract. Each game, to be clear, has its own Layer 2 smart contract, which is actually very unique compared to all other Layer 2 solutions currently out in the market. This allows your nodes to actually sync orders of magnitude faster, because if everyone is using the exact same contract, then suddenly your game node may have to parse, the input submitted by 1,000 different games. Instead, by deploying your own contract, you have the freedom to also earn transaction fees from your game by people who submit to the contract. You have the ability to expand the contract as you like, and you get the syncing benefits that I just mentioned. And so this new approach provides a lot of small but quite integral benefits that are useful. Nonetheless, once the user submits the game input to the smart contract, the smart contract is watched by something called the chain funnel, or specifically internally, Paima funnel. So this is a part of Paima Engine proper, which fully clicks in place with the rest of the stack and allows your game node, so this is the actual node running your game logic, and specifically your global game state machine, which we'll get to in one moment. So Paima funnel reads from the smart contract, sees all of the game inputs that users submitted, either through Paima Whirlpool or directly to the smart contract. And then it processes the game inputs. It does a bunch of internal stuff, including signature verification, nonce generation, and some other validation to ensure that whatever is submitted to the smart contract is now in a good and solid parsable state that can then be passed on to your game state machine. Paima funnel / chain funnel also has a bunch of other features which in the future will improve syncing speeds. It also implements core functionality to make stateful NFTs possible, and a lot of other good stuff. Next up, we can jump on over to the game state machine and start to get an understanding and feeling of how do you actually write the global logic of your game. So the one really interesting thing with Paima Engine is that whenever one user submits a game input, this causes a state transition function to run. And so what this means is that your game is implemented as a state machine, which moves from a state A to a state B. And specifically to go through that state transition, we have a state transition function. And this is a fully deterministic function that always transitions A to B given the same input. And so this sort of pure determinism that we have is quite unique in the context of game development for a lot of people. However, it's not really all that much more challenging comparison to more imperative and classical styles of game development. However, it provides us countless benefits that actually enable Paima Engine to deploy your game as a full-fledged layer 2. And so in other words, you get everything for free by just simply implementing your game within the structure of a state machine. So what does this mean in practice, right? So the game state machine that you write is specifically a game state transition function. And so you have a game state database. So you define a schema for your database. Currently, we are using Postgres as the default. And what this allows us to do is you define all of your state and the schema for all the state that your game will need in a classical, robust, and strong database like Postgres. You have a state transition function which holds all of your actual game logic that moves the global state. And so when Paima Funnel reads game inputs from the L2 smart contract, it then passes it into, through the runtime, your game state machine. A state transition function is run using the inputs from the user and using the current global state, which is found in the database. And then your state transition function processes the input that the user submitted, verifies that it's valid. Like in Jungle Wars, we check that, if I submit moves to a lobby, I'm actually a player in the lobby, those moves make sense, and so forth. Then, once all of that is processed, and all the lobby-related logic, part of the state transition function is executed, we then go into the round executor once more. And so the actual gameplay, so for example, in Jungle Wars, our first game, the actual application of, okay, I chose to fire at position 2 of my opponent, and then using a randomness generator, which is baked in for free, provided to you as a developer using Paima Engine, you have a baked-in source of randomness that you can always use through a really simple-to-use interface. And so with this RNG generator for Jungle Wars, we determine whether the move where I wanted to fire at position 2, and I, let's say, had a 80% chance to hit, 20% chance to miss, that logic and that deterministic checking of that randomness of whether I do hit or I miss, that happens in the round executor. And that's actually where all the core gameplay is used. And so to reiterate, the round executor is used in your state transition function to move your global game state from A to B. And it is also used in the front end to replay that part of the global state transition function to the player. And so the round executor is both a subset of the game state machine, but also something that gets exported into the middleware / front end world. And so just to wrap that up, effectively, your game state machine is your global game logic, and every game input that any user submit goes through your state transition function in your state machine. And by doing that, all of the updates, so, the round I played in Jungle Wars, I submit 3 moves, I fire 3 times, I hit all 3 times by chance, and then I win the match. The effect of me winning is something that is the result of the state transition function, right? So the round executor is used in the state transition function, and the output of the state transition function, the output of the round executor is then made into the output of the state transition function, which then is applied into the game state database. So in other words, all this game logic runs, it works, it gets applied, and then we actually move officially, once the effects of the state machine are applied to the database, we have officially transitioned from state A to state B. What this means now is that we have a web server attached to the game state database. This is all part of the game node and part of Paima Engine runtime. You now, as a player, can use the middleware to then query the web server to find out what is the new state, right? So in my case, I know because I submitted the moves that I fired at the opponent 3 times. And in the game node, it executed everything, used the randomness generated by Paima Engine runtime, and it actually showed the results. And not only showed specifically, but it executed the results and then saved it to the database. Once it's been applied, then the web server is used both by me as the player who submitted the moves and my opponent. We both use our own front ends, which go through the middleware, to query the web server of a game node and then find out what were the results, and then specifically to request a round executor from the middleware, so then the front end can actually replay what happened in that round. And so in our case, the replay would show I fired 3 times and beat my opponent. And so these effectively are all the high-level base parts of Paima Engine and writing a game that uses Paima Engine. To quickly go over that again, your front end is your classical Unity, Unreal game engine that you use to actually visualize everything that happens from the user's perspective and provide a UX/UI that's exciting and feels and actually is a full-fledged game. The middleware is used for both reading from the game node/backend, for generating a round executor and bringing that back to the front end. It is also used by the front end to do writing, to actually apply changes to the global game state. And that goes through from the front end, through the middleware, to the user's wallet, to the smart contract on-chain, and finally to the game node. Once that game input is in the game node, it is taken from Paima Funnel by the runtime and passed into the game state machine that you as a developer write. The game state machine processes everything using the round executor internally, and then the end results of the state transition are then applied to the database. Once this application has been finished, we effectively have this full loop, where then once again the middleware, which has the ability to read, can contact the web server and find out what are the new state updates, and then bring those over and visualize them on the front end. And so just like that, end to end, we have both a reading loop and a writing, a part of the loop. And together, this is how you implement and how you integrate a full end-to-end game using Paima Engine. Now that we've looked at how games are implemented at an architectural level, let's jump right into actually looking at an example project, specifically chess. This is the turn-based template that will be shipping with Paima Engine, and this allows you to learn the basics of how do you create a PvP lobby-based game where every round within the lobby/match a player, and specifically a single player, has the right to submit one or more moves. And so, unlike in Jungle Wars, where two players submit moves in the same round, with chess, only a single player goes per round. We're going to dive in right now to each of the various folders here with code. And I'm not going to go deep into every implementation detail, because that would likely take a few hours to really flesh out and explain everything in depth. But we're just going to jump into the different sections of the chess template so that you can start to get a feel of, at the code level, how does that actually end up mapping onto the architecture that we just went over. So let's jump right in. First things first, as we mentioned, your game is at its very core a global game state machine. And to build a state machine, what you have to do as a developer is write a state transition function. And so in the template, you'll find a state transition folder. And in this folder, you will have subfolders, which specifically are STF and V1. We provide developers the ability to implement a state transition router, which allows you to have multiple state transition functions and at specific block heights, effectively by itself via Paima Engine, allow your game state machine to switch from version 1 to version 2 or from version 2 to version 3, and thus have this seamless update path that, even though these are fully deterministic systems, by scheduling an update, say in 2 days or 1 week forward in block heights, you can allow everyone to have enough time to update the node, and then everything will just seamlessly move forward, allowing your game to have real updates even with full determinism, which is quite exciting. Nonetheless, in this subfolder, we only have specifically a version 1 because chess, last time I checked, is not being updated anytime soon. In the STF folder, in this case in the version 1 folder, you'll find that specifically what we're doing is, let's just jump back to the architecture. We're wanting to implement a state transition function for a state machine, which means that we need to take user inputs that are submitted, which was originally submitted to the contract, and Paima funnel, which is part of Paima Engine proper, automatically provides the data for our state transition function to process. And this also includes already automatically generating a randomness generator and also a randomness seed, which seeded the generator. And all of this is provided with the input data being from the chain itself. So the user inputs is part of this, the block heights, the randomness generator, and a connection to the game state database. So from your perspective as a developer, your goal is to emit a list of SQL updates to your database that are the result of the state transition. So to break that down, what we're doing in the state transition function is not explicitly mutating the database. So we don't allow you as a developer to at any point edit anything in the database, but the game state machine has the full access to read anything from the database, but it must, in a pure functional fashion, return the list of updates, which then Paima Engine itself applies into the database. This is required both for a coherency's sake and also specifically in the realm of parallelism. It will allow us to make Paima Engine really robust and add in effectively as a baked-in primitive concurrency so that eventually your games can scale to countless machines if needed, if you have extremely intensive computations required. And so these are kind of first principle requirements that were designed from the ground up, especially when I started looking at what is the requirement for Paima Engine to really work as this Web3 engine. This more functional state machine approach is what allows us to have so many benefits upfront. So I won't dive too much into the nitty gritty, but effectively your state transition function takes these as inputs. It specifically reads the input data. So you can see we have a parser file here, which parses the game input that the user supplied. And you can see here, so we have this parse function, takes the input data that the user supplied, and it pops out an expanded variable, which then we switch on, and then we process with effectively different strands of global game logic as a part of our state transition function. So effectively, in chess, you can either create a lobby, join a lobby, close a lobby, or submit moves into a lobby. There's also scheduled data, which is a primitive of Paima Engine that enables passive time. However, we won't get into that in this video. In short, what we're doing here is we're taking the inputs that Paima runtime provides to our state machine, to our state transition function. We're parsing the user input specifically. We're checking what is that user input. And if that user input is incoherent, then we do nothing, and that input is simply thrown away. And so an empty list of SQL updates states that the input didn't pass validation, there's nothing to do, just continue on with the next user input, and your state machine will continue forward. However, if it is coherent, and it's either creating a lobby, joining a lobby, closing a lobby, or submitting moves, then we write logic for each of these cases. And so I won't jump too much into these, but effectively in the transition.ts file in the STF folder, you'll find all of the different functions for creating a lobby, joining a lobby, and these either directly create the SQL updates. And so we have persist functions in the persist folder for persisting and generating the SQL updates that will be applied into the database. And for more complex actions that the user can take, like closing a lobby or especially submitting moves, which requires generating a round executor, running the round, and then applying the state to the lobby and saving it to the database, these functions get more and more complex. Obviously, none of this is really too crazy because chess is actually quite a approachable game to understand and deal with, but pretty much you can understand the state transition function and how it mutates global state by just looking at the index.ts and then moving forward from here. Jumping back upwards, the state transition function, as I mentioned, is how you actually move forward global states. But we mentioned there is the round executor, which the state transition function uses, and the the round executor also is used by the front end, as we identified in this graphic. And so what we're doing in the game logic folder is creating an interface for actually generating a round executor. The round executor is created using an init round executor function. In lobby-based games, typically the main inputs for this would be the lobby data itself, the user inputs or the moves for that specific round that the user submitted, and the randomness generator. Out of the lobby state, we then extract a match environment and a match state, where the match environment are parts of the lobby which do not change or which should not be mutated. And so in our case for chess, that's what's the color and what's the wallet of each user. And the match state is actually what is to be mutated when the round executor is processing. In our case for chess, that's just the board state itself. Out of here, we have one more thing that's of note. We do have some chess logic that implements the actual logic of chess itself. We have some types on the side, but primarily in the game logic folder, you'll be looking at the index for actually generating the round executor and the tick file. The tick file is actually the logic of your round executor and how it will be evaluated. So your round executor is this object that takes the tick function as an input, process tick in this case. And what it does is It takes your match environment, it takes your match state, it takes the moves that are submitted for that round, and also the current tick, which the round executor provides automatically to the process tick function, so you know how many ticks have happened. And to be clear, a tick is the lowest amount of time that can process in a round executor. So it's one execution of your round executor. What this does is that on a tick-by-tick basis, you play through a round and return either a list of events or null. In our case, with chess, we only need a single tick because when you place down a piece in chess, the effects are effectively just that piece has moved, right? In games like Jungle Wars, we have 6 ticks is the typical amount because each player submits 3 moves each, and so together 3 plus 3, we have 6 ticks through a round. Without getting into the nitty-gritty, effectively what you do in your process tick function is you take all of these inputs that are relevant to the round that's being executed. So in our case, we just look at what's the move that someone supplied, what's the current match state. You generate events, and these events are specifically JSON/objects that you want your front end to be able to interpret to know at a tick-by-tick basis what is actually happening in the round so the front end can visualize. And so by creating these tick events, you can then apply them to the match state, which we have an apply events function to do that. And so we do 2 main tasks in the process tick function, meaning that we emit, so we return a list of events. For chess, there's only a single event that's required. And this is used by the front end to visualize the actual actions in the gameplay. And we apply these events into the match state so that when the round executor finishes, then the new match state is returned from the match executor as the actual output of it finishing its process of execution. This model allows us to use the mutating of the match state to make sure that everything's moving forward, and the final match state, the end state, actually is used by the game state machine to then apply that to the database. While on the front end perspective, the round executor, the tick events, explicitly are used by the front end to know every step of the way as the round was executed, what happened, so then the user themselves can see. And so these at their core are really the main parts of your game that you're implementing between the state transition function and the game logic. There are other folders here. So like the API is specifically so you can create all the endpoints that are served by the web server to expose the game state database externally to the middleware. We also have the middleware itself, which allows you to have this, center point between the front end, the wallet, the game node, and everything together, and bring that all together. And lastly, we have a utility library that just holds some basic defaults that are relevant to the game. And lastly, we have the actual database part of the project. So this database effectively submodule allows you to define basics like what is a lobby specifically, what are the different things it has, creating different tables specific to your game. Some games, you might have tables related to NFTs. Other games might have, in an open world context. You may have lots of user state and maybe various tables for user state. Effectively, the database part of the project allows you to define your schema for your game state, and then we use a specific library called pgtyped that allows you to really easily and declaratively specify your full database and all the tables required for your game and expose that directly in easy to use TypeScript imports that you can then use in the middle of your code to easily create queries that then your game state machine returns from the state transition function, and which then get directly applied to the game state database. And so lastly, to wrap up, I want to show off just how you actually compile the code for your game that you've written. And then once the code is compiled, how do you use Paima Engine to actually run it? So when you first pop out the template, you have to run npm run initialize. But once you've had the project initialized, all you have to do is hit npm run pack. This takes all of the code in your game or the template you're using, and then bundles it up into two separate files, one being endpoints and one being game code. The endpoints file specifically has everything from API, and so this is what's used by the web server in the Paima Engine runtime, and that's how all of the endpoints are hooked up. And the game code specifically takes your state transition function and brings it all together to then be able to be used directly with Paima Engine. Now that we've packed the game code, all we have to do is type /Paima Engine run. In this case, the game node has started. I've already set up a config file that's targeting a deployed smart contract. And now we see that the web server started using the endpoints that were just packed in the endpoints.cjs. And from here, you can see that our game node has begun syncing and processing blocks. As you see, I've had this game node offline for about half a day at this point. And so we are processing a lot of blocks at a time. So the Paima funnel, part of Paima Engine currently, syncs blocks in batches of 100. And this will likely, as I mentioned prior, be optimized and become even more efficient in the future. But effectively, it's catching up from the last block height that it saw, and it's going in batches of 100. As this keeps progressing, as you can see right now, because this is just a smart contract I deployed, and there's no one else playing with my random smart contract, there are no game inputs currently being run, but it's still syncing at quite a fast speed, as you can see, about 100 blocks every, let's say, 3 or 4 seconds. So as such, it's really just that easy for using Paima game templates to get up and running. We have documentation that ships together with the Paima Engine standalone, which takes you step by step in setting up and deploying your own Paima L2 contract. You have the ability to initialize templates through the Paima Engine executable, and altogether, you can pretty easily, understand at an architectural level how all of this works, and then using templates, you can start to go, file by file and start to understand, okay, how do I actually write my first state transition function? Okay, what is actually the way to have various inputs from my lobby and maybe external state and put it all together in the round executor? And you can kind of go step by step and really understand end to end how do you use Paima Engine to create a brand new class of Web3 games. Furthermore, we will be releasing more videos, tutorials, and guides for taking you through and understanding all the different parts of how do you actually write a game using Paima Engine. And unfortunately, at the very moment that we've released this video, Paima Engine is currently still in a early preview state. And so if you are a company who's really excited, you're really dedicated to Web3, or you have a great experience building games that people love, we would be really excited to work with you and provide you an early access to Paima Engine so that we can iterate together and move forward to understand, where are the best places we need to improve. And over time, our expectation and goal is for this year, as we work with more and more companies, we build and continue to build more games using Paima Engine, we start to really refine and get all of the essentials really solid and foundationally in place. And once all of that's done, writing great documentation, guides, videos, and more, so that everyday devs and game devs have the opportunity to actually start to learn and use Paima Engine in a practical manner. Once we bring that all together, then we're going to be really excited, and at some point in the coming future, we will be announcing the public release and availability of Paima Engine for everybody. Until that happens, we're really excited to bring you videos like this to give you your first taste, and that's not completely surface level, but actually gives you a understanding of how Paima Engine works. And sooner than later, you can actually expect to use Paima Engine for yourself. So we're really excited to be here on the bleeding edge, building all of this with you guys. So to wrap up, if you're really excited and you're more of a player or a developer who builds games on the side, we'd be really happy and excited to have you as a part of the Discord community on Twitter, and really just jump in and start discussing with all of the most excited members of our community of potential games and what just might be possible using this technology. If you're currently a game development studio, a team that has a solid track record, feel free to please contact us directly, and we can kind of talk and start to move forward and see if Paima Engine might be a good fit for your projects or a new project that you're looking to create, or as a way to enter into the Web3 space. With all of that said, I'm really excited to be able to, be building Paima Engine. About 1 year ago, this was just a crazy idea in my head. And then after, countless documents, white papers, and more, we've really come to a point where Paima Engine works. We've shipped Jungle Wars, our first game, and we're really refining the interfaces, the underlying libraries, and all the core functionality of Paima Engine so that it's really not just enjoyable to use, but it's truly feels like the next step in Web3 game development. We're not trying just to create a template or a framework that makes it easier to just write games in Solidity. We're really starting from first principles, and I'm really excited to be able to share this with all of you. Thank you so much for watching. All the links for contacting us, Discord, Twitter, and more will be down below, and have a great day.